Hello everyone. In my earlier video, I have shared with you about the Newton's second law in theory only. For now, we proceed on to the application. Again, we consider a mass of 4 kilogram, and this resultant force cause the mass to start moving, right? To start moving. And the resultant force acting on this 4 kilogram is 20 minus 15 will give you a 5 Newton resultant force. And this 5 Newton resultant force is actually in a direction towards the right. Okay, and the 4 kilogram mass will actually accelerate to the right, which is in the same direction as the resultant force. Now, using Newton's second law, how do we determine the acceleration of this 4 kilogram mass? We do know that from Newton's second law, F net equals ma. And I decided to call this F2 and this F1. It depends on how you label it, it's pretty much up to you. This is your mass M. So F2 minus F1 equals MA. Okay, let's backtrack a little. I think some of you will be asking, why not F2 or F1? Alright, now because I already know that the direction is already to the right. So to simplify matters, I want the direction to the right to be positive. So I'll make sure the force F2 will be bigger. Right, so I take F2 minus F1, it will give me a positive resultant force. See, to make things simpler, alright? And hence, F2 equals 20 newtons, F1 equals 15 newtons. So I have 20 minus 15 equals mass, which is 4, and acceleration. And using mathematical manipulation, you will get A equals 1.25 meters per second square. So in this case, I have a positive acceleration. And how do I interpret it on a velocity time graph? This will be my velocity time graph. I know it starts from 0 because starts moving. So it starts from rest. Okay, and by down 1.25 meter per second square, you should be able to deduce that if this point here is 1 second, this point here should be 1.25 meter per second. Please seek help if you are not able to understand this. Let's consider another scenario. This time around, you have a 20 Newton force that's acting on a moving object of mass 5 kilogram. See, acting on a moving object. So this object is really moving, right? And a 20 Newton force acts on it. And there's an opposing force that acts on this same object. And from this diagram, you can see that the opposing force is 30 newtons. Now, resultant force acting on the 5 kilogram this time round is 20 minus 35 equals minus 5 newtons. Sorry, this should be 35. Alright, let's say 20 Newton force to the right. Okay, to the right. Right, so anything to the left will be negative. And hence, right now you have a minus 5 newtons. Now I'll share with you how to process this minus 5 newtons. Okay, it can be both accelerating to the left or decelerating to the right. Right, it depends on your depends on the perspective. Right, let's proceed on here. The resultant force now is negative, and this suggests that either object is decelerating to the right or accelerating to the left. And from here, F net equals MA. Okay, and I'll take this is F2 and this is F1. Right, F2 minus F1 equals MA. So 20 minus 35 equals mass, which is 5, and A, acceleration. And A equals minus 3 meters per second square. Minus 3 meters per second square you have this gradient. Okay, and again, I'll tell you, once you're familiar with it, you should know this is 3 meter per second, and this one here, which I wrote, is actually the 1 second. And by now, you should have sufficient practice to know that the gradient is negative. Right, this is the negative gradient. And that is why your answer is negative. But it depends on which part of the graph the motion lies on. The red line which I've drawn shows that 5 kg mass is decelerating. And if these two forces, 20 newtons and minus 35 newtons, continue to act, they continue to act. Alright? Once it reaches its maximum displacement, it will start to accelerate in the opposite direction. So this refers to 5 kg mass accelerating. That's why I said when the resultant force is negative, depending on perspective, it can be decelerating or it can be accelerating also. Right? You need to go back to the graph and analyze it. Okay, the number itself merely shows you the direction, the magnitude and the direction, but it does not give you additional details as to whether the 5 kilogram is decelerating towards the right or accelerating towards the left.